Hello, this is Tim Pavlak again with another example using the ANSYS Workbench simulation application and its many features. Today we'll be using the mechanical simulation available in release 12.1 to solve the linear vibrations of a simple house fan. Let's start by dropping in a modal system into the ANSYS Workbench project schematic and then searching for the geometry of the fan. So I've selected that. Now let's open up the geometry model inside the mechanical simulation application. Our goal was to solve for both stress-free and pre-stress modal frequencies and then to summarize the results in an automatically generated report. So my first objective is to set up a simple stress-free modal analysis. Here you see the geometry inside mechanical. All I have to do is decide where the fan will be re-rotating, and I'll zoom into this location, select this edge, and define a fixed support. At this point, all I need to do is specify the number of modes I'm interested in. Let's pick 3 modes and compute the solution. You see that the software is now automatically generating the mesh and it's now computing the solution. It's finished, and I see in this table that I have 3 frequencies solved for as requested, ranging from 105 Hertz to a little more than 122 Hertz. So that's my baseline stress-free modal solution. Now let's go back to the project schematic and duplicate this analysis because I want to do another modal analysis. So I'll duplicate this, and also in this duplicate modal analysis this one needs to be stressed, so I'll transfer data from a new static structural analysis into this duplicate modal analysis. And then I'll go back to mechanical and I see there's been 2 additional branches added to the simulation. I can set up the static structural analysis by dragging the fixed support on that center hole in the fan down to the static analysis and then adding an additional load of a rotational velocity. In this case I want it to be a rotational velocity of 2000 RPMs about the x-axis. So you see it's going to be simulating a rotation about the x-axis. And I'll request a stress result so we can review that and perform this solution. Just to take a look at the stress result. You see here there's 89 megapascal stress in this fan. And because I'm going to be generating a report, let's go ahead and drop a figure in for this stress, and that means it'll be included in the report later when I generate that. Now let's go back to the second modal analysis. This fixed support is not needed in this modal analysis, so I'll delete it. I'll redefine the number of modes. Since it was duplicated, it's remembering the 3 modes I requested from the earlier analysis, and I'll perform the solution, the pre-stress modal solution on this version of the model, and I see here that my frequencies are now computed. I have, instead of 105, 112 Hertz, instead of 122 maximum frequency, I have 130. So my 3 simulations are complete: the natural frequency without stress and the mode frequency with pre-stress. Now let's go to the focus of my exercise here, and that's to show you how I can generate a report very automatically. If I click this tab in the mechanical window, I see the software is automatically generating a report for me, and it puts an automated picture at the top of the report. And if I scroll down to, or use the outline to select the solution of the natural frequency, I see they're included in a table 112 to 130. And then I can also, that is the stressed frequency I should say. Here is the frequencies for the natural frequency. It's 105 to 122. And also I can see that there is a figure of the stress for the fan in this case as well. So I have a report in the software. Now I need to find out how to send this to my colleagues or to my boss or to my customer. Workbench Mechanical offers several ways to do that. I can click the Send to Report option and send it to PowerPoint. It will open up this report information in a PowerPoint document. putting in some of the basic figures as you see here in the PowerPoint slides, and also some of the bar charts representing the frequencies and any figures I included in the application simulation that I performed. So now let's go back, and this can be all edited as you would normally edit a report. I can type in stress and make those changes in PowerPoint. Let's go back to mechanical and show you another option for managing the report. I can send it to a Word document. In this case, Microsoft Word will open up, and all the contents of the data, both input and output data, are included in the Microsoft Word. This report is a little bit more elaborate. It has links to different locations in the report. It also includes a lot of technical details about the data that was used to generate the simulation, as well as the tables for the solution. Scrolling down, we should see here shortly a table of the solution for this stress-free frequency, the 105 to 122, and we also see another table for the pre-stress frequency, 112 to 130, and down near the bottom is a picture of the stress solution. And one last option, you can actually click send your report as an email attachment. That'll include this in Microsoft Outlook or your email application and send it there. So wrapping up, your takeaway here is you can see how mechanical can be used to automatically generate reports, and you can communicate your work with your colleagues or with your customers. This ability to generate reports applies to a whole host of different simulations. Hopefully this is interesting to you, and I look forward to sharing more information about ANSYS Workbench in future episodes.